Hello and welcome. My name is Ashish, and today we will be exploring the Pyspark and K-means clustering method to basically demonstrate how that process works out on the Cloudera system. For that, we are taking one of the datasets called Iris dataset. Dataset looks like this. So this is a dataset where the flower iris has different uh, variants called setosa, versicolor, and virginica. And there are some fields which we will consider and predict which flower is it. And basically, when we are doing k-means clustering, we'll calculate the mean square error. And for that, you first need to go to the Hue file browser, and in Cloudera, user Cloudera, first you need to upload your file, new file, and upload the iris dataset. I've already done it here. After that is done, we'll go to the k-means clustering code here, and once you go there, you'll see that we are importing Pyspark machine learning library, and we are importing k-means and k-means model, and then we are importing numpy and pandas and math function, Pyspark, Spark context. We are creating one Spark context SC, and which we'll be referring throughout the dataset. So back to the iris dataset. So first we'll run this, and this is creating a Pyspark context. Next we go to the we'll import the iris dataset, and since it's a comma separated file, we'll be parsing the dataset, and this is the code that is used for parsing the dataset. Once we pass the dataset, it will show us this output, and then we display the first three lines by using this take function. We can pass any number of lines and we can get the output accordingly, if you can see that. Next, we select the parameters which we need to use for predicting. So here we are using the first, second, third, and fourth rows, that is 1, 2, 3, 4, all the numerical parameters we are using for doing the k-means clustering. So that takes the parameters, and once you want to display the parameters, so these are showing you the only 4 rows as we have seen earlier. After that, we will define the error function using the square sum of within sum of square errors, and this is used. This is defined by this formula here. Next, we will display the sum of square errors for this, and if you can see, it shows like 105.35 within maximum iterations 50, and runs of this training model is 50. If you press shift tab on this, you can see basically all the arguments which goes into studying this. So epsilon value can be varied, and we can play with it and see how the maximum iterations and runs come out to be. For this case, our mean squared error converges at 105.3586. So it's that's basically predicting the mean square. So where the sum of square error stops, we'll stop our iteration. So that is it. Thank you for watching.